Hi everyone, in today's video we'll be graphing reciprocal functions of quadratics. With that said, let's get into the video. If f of x is equal to x squared plus 4x plus 3, sketch 1 over f of x. So what I would do in this situation is that I would first sketch the graph of f of x, and that is a simply quadratic graph. So what I would do is that I would take this, I would write y equals x squared plus 4x plus 3, right? And then I would factor this out to find the x-intercepts. So I would say that, okay, just graphing a quadratic equation, I would say x plus 3 multiplied by x plus 1, is equal to 0. So I would know that my x1, my first root is -3, my second root is a -1. So I would go here, I'd say -1, -2, and -3. So I will plot this right over here. Actually, to make it a bit more accurate, -3 right over here. I just circled these bits. And then my y-intercept is 3. So I'll go here 1, 2, 3. Alright. And now my vertex would be, if I would just write this in the vertex form, I would have y equals x squared plus 4x plus 4 minus 4 and then plus 3. So I'd have y equals x plus 2 squared, and then I have minus 4 and plus 3 outside, so it's just going to be minus 1. So my vertex coordinate is -2 and -1. Alright, so -1 would be somewhere around here, and -2 is somewhere here. Alright, now just sketching this graph. Alright, we've graphed our f of x, and that is x squared plus 4x plus 3, but the question is really asking us to graph 1 over f of x, okay? And that is equal to 1 over x squared plus 4x plus 3, alright? It's a bit different, and it looks like it is a rational function, alright? So if we would go ahead and factor this graph, so if we'd go ahead and factor this expression, we'd get something like this, right? Just same thing, x plus 3 and x plus 1, right? Same, right? So what happens here is that, okay, we can easily identify what is the vertical asymptote, right? The vertical asymptote would be here -3 and -1, right? And you might say, hold on, the vertical asymptotes are my x-intercepts. Alright, so easy. We already got the first idea. Well, we got that. We said that, okay, my vertical asymptote in this situation will always be my x-intercepts in my quadratic graph. Okay, so let's go ahead with a different color, and let's go ahead and indicate our vertical asymptotes. Our vertical asymptote is x equals to -1. That is one of them. Oh, that looks way off. So that is our first vertical asymptote, and our second vertical asymptote is x equals to -3. So looks something like this. Oops. Yes. So now that we have our vertical asymptotes, let's go ahead and indicate something else. All right. We see that in this graph, our horizontal asymptote is always going to be equal to 0. It's y equals 0. And that is simply because our function can never be equal to 0. Alright? In this situation, when the numerator's power is less than the denominator's power, then your horizontal asymptote is always going to be y equals to 0. So let's go ahead and indicate horizontal asymptote with a blue dashed line. Okay? So this is y equals 0. Alright, great. Now, when we plotted our vertical and horizontal asymptotes, we're left with 3 sections here. We have the left section, we have the middle section, and we have the right section, okay? Now you might be wondering what to do with these three sections, and don't worry, it is actually pretty easy. So always try to start off from the middle section, and that is, you have a small parabola right here, okay? It's a small parabola, alright? So what do you do with this section? Okay, so whenever you graph a reciprocal of a function, this section will always flip, meaning that if you have a minimum point, it is going to be your maximum point now. So this is actually our minimum point, right? -1 is our minimum point. Well, now it is going to be our maximum point, right? So the graph, the small parabola right over here, it is going to flip, okay? It's going to flip from its original position. Not only that, but it's also going to be the reciprocal of its y coordinate in its vertex. So if my vertex was a B, my new vertex would be a 1 over b, okay? My x coordinate stays the same, but my y changes. So what will happen here is that my vertex was what? My vertex was, this was my initial vertex, right? My vertex was -2, -1. Now my new vertex will be -2, -1 over 1. So basically, it's still -1, it really doesn't change, and what we're going to do is we're going to flip this right over here. Now, -2 and -1 is our new maximum point, not minimum, but maximum. So our graph's going to look something like this, okay? Alright, parabola, however, it is flipped upside down, and it goes on like this, okay? Now that we've sorted out our middle section, let's go ahead and look at our left and right section. Now, the left and right section performs similar behaviors, so they're kind of like the same behaviors. All right, so what do they really do? So there's this rule in when you graph a reciprocal function, and that is if your f of x approaches towards 0, your 1 over f of x will approach towards positive or negative infinity depending on your situation. Alright, so let's go ahead and analyze this real quick. Alright, so I organized the screen a bit, and let's go ahead and look at this factor right over here. It says that as my f of x decreases, meaning reaching towards 0, my 1 over f of x will go towards positive or negative infinity. In this case, it is going to be positive infinity because, as you see, our quadratic is positive right over here. It is concave up, so it's going to go in positive direction anyways, okay? If it was concave down, it would have gone in negative direction, but in this case, it is concave up, so it's going to go into positive direction. And what this really means is that, okay, we said that let f of x be a, okay? Let f of x be a, any number, all right? And 1 over f of x is 1 over a, right? So if you actually decrease your f of x, meaning if you decrease your a, your 1 over f of x will actually increase, because if you decrease the value in your denominator, your fraction actually increases in value, your result increases in value. And if you increase your f of x, meaning that if you increase a, our value 1 over f of x will actually decrease. And that is just basic algebra. Alright, so now let's go ahead and dissect the graph a bit, okay? And we see that as our graph is approaching towards 0, we know that our 1 over f of x must rise. It must rise towards positive infinity. Same thing goes on here. As our graph is approaching towards 0, as our f of x is approaching towards 0, our 1 over f of x must approach to positive infinity, okay? Now let's go ahead and indicate this in the graph, okay, to see how it actually looks like. But before we do so, we also have to acknowledge that our y-intercept right over here, it is also going to be the reciprocal of it. So if our y-intercept was 0, 3, our new y-intercept is going to be 0, 1 over 3, alright? So it's going to be somewhere around here, okay? Let me just write 1 over 3. Alright, so my graph will look something like this. Okay. Here's our horizontal asymptote, and it's gonna look something like this. Okay, just to be more accurate. Alright, so it's gonna look something like this. Okay. Now that you see that, okay, as my f of x is approaching towards 0, as my original function is decreasing, my new function, 1 over f of x, is increasing. And that's just simple proportions, like you decrease the denominator of your fraction, your whole general result increases. So that's just simple properties of, fractions and all that. So now that we can delete our f of x, the red one, we're left with 1 over f of x. Okay, and we can simply write that this is 1 over f of x. Okay, this is our graph. Okay, we can just delete this too. All right, so yeah, this was 1 over f of x. All right, so let's have a look at the second example. So f of x is equal to negative x squared minus 5x plus 6. Graph 1 over f of x. To do this, I'm just going to casually go ahead and graph the f of x, a quadratic function, negative x squared minus 5x plus 6. I'm going to equate it to 0 to find the zeros of it. So I'm going to find x squared plus 5x minus 6 equals to 0. And I'm going to do x minus 1 multiplied by x, actually x plus 6, yes. So I'm going to equate to 0. So my x1 is 1. My x2 is negative 6. So just graphing this right over here, I'll plot negative 6 over here. I'll plot 1 here. And my y-intercept is 6. So it's going to be somewhere around here, right? And what I will do here is that I'll try to find the vertex. The vertex x-axis of the x-coordinate of the vertex is 2.5. So 2.5, negative 2.5. And y-coordinate will be, since this is a calculator allowed question, you can just plot this point into your function f of x, and you should be able to get 12.25. Okay, so 12.25, somewhere around here, I'd estimate. Okay, not very accurate, but still. And negative 2.5 would be somewhere around here. Alright, so just drawing the graph, right, it's gonna look something like this. Okay. Alright. That is a terrible looking quadratic graph. I'm just gonna try to do it again. Well, we start from here. I should be able to get something like this. Well, alright. It is a terrible looking quadratic, but at least we can do something with this. Alright. Now, we have our vertex, we have our vertex, we have everything, we have the coordinates, we have everything we need to know. Alright, now let's go ahead and graph 1 over f of x. So that we know that our x-intercepts are going to become our vertical asymptotes, so let's just go ahead and indicate that real quick. So negative 6 is going to be my vertical asymptote, x equals negative 6, and x equals 1 is also going to be my vertical asymptote. Alright. Alright, so we also know that this is our maximum point. This is actually a concave down graph because of the negative sign right over here. So we know that this is our maximum point, 12.25. 12.25 is our maximum point, and we know that our maximum is now going to become our minimum in our 1 over f of x graph. And we also know that our y-coordinate of our vertex is going to become reciprocal of its own. We know that our vertex is no longer going to become negative 2.5 and 12.25, but it's going to be instead, let me just indicate this, vertex is going to be negative 2.5 and 1 over 12.25, okay? It's going to be its reciprocal. And it's going to flip, meaning that it's going to change to maxima to minima. So it's going to be minima point right over here, minimum point. Let me just indicate this 1 over 12.25. It's really small value. So it's just going to mark this right over here. And our graph will look something like this. Okay. Alright. So we see that, the graph flipped. The vertex coordinate, the y-coordinate of its vertex, also became its reciprocal. Alright? We also know that actually our y-intercept is going to become its reciprocal. So I forgot to mention this, but here, right over here, as you see this intercept, it's going to be actually 1 over 6, okay? And so our horizontal asymptote is again 0. In this case, it's always going to be 0 because we know that anything divided by 1 can never be equal to 0. So our horizontal asymptote is 0. And then we've left with the graph right over here. Okay, we've left with the left and right section. All right. So we know that we said in the previous example that as our f of x approaches towards 0, our 1 over f of x will approach towards positive or negative infinity. All right. In this case, it is going to approach negative infinity because our f of x is in the negative direction, right? It is concave down. So when we see that this left and right section is in the negative direction, it's going to be always 1 over f of x is always also going to be on the negative direction, all right? And as this is approaching towards 0, our 1 over f of x is going to rise, okay? Our 1 over f of x is going to rise. So it's going to look something like this. Like this, and like this. The graph looks very wobbly, but I mean, it's all I can do. Alright, so my 1 over f of x is going to look something like this, alright? And now if we just go ahead and delete our f of x, we should be left with a graph like this. And this, guys, is the graph of 1 over f of x. Alright guys, this is the end of the video. I hope you enjoyed it, and I hope you learned something out of it. So please make sure to subscribe to my channel and like this video in order to keep the channel running and for me to constantly posting videos. And please share these videos amongst your friends, spread education, and yeah, that was it for today. Bye.